In this video, we're going to use some basic trig identities to prove these two identities. These basic identities are sometimes called fundamental identities. So when you prove an identity, you either start with the left side and show how you get the right side, or start with the right side and show how you get the left side. You don't want to start with equality, because otherwise you're assuming that it's already an identity and you're trying to show that or prove it. So let's start with the left side. Got cosecant to the fourth theta minus cosecant squared theta. And for this one, we're actually using this identity, fundamental identity, basic identity. Tells me that 1 plus cotangent squared theta, this one's also called a Pythagorean identity, is equal to cosecant squared theta. So on the right side we have a cotangent to the fourth and a cotangent to the second. The left side we have a cosecant and a cosecant. So I want cotangent to the fourth, and I have a fourth right here. So I'm going to use this right here. So this is cosecant squared. So this is going to be 1 plus cotangent squared theta. So in other words, think of this, what I have right there, as cosecant squared, but it's actually cosecant to the fourth. So I need another square right here. And this is minus cosecant. I don't have any cosecants on the right side. So for this cosecant squared, I'm going to replace it by using this identity here, 1 plus cotangent squared theta. Replacing this one here again, that's cosecant squared, and then it's squared. And I just square that. Square the first term, that's 1, plus double that product, that's 2 cotangent squared theta. And then I square the cotangent squared, gives me a cotangent to the fourth theta. Now for this part, I just distribute the negative, so that's going to be a minus 1 and a minus cotangent squared theta. I got a 1 here and a minus 1 here. That cancels out. Got a cotangent to the fourth theta right there. That's going to be part of the answer, cotangent to the fourth theta. Then I got 2 cotangent squared theta and a minus cotangent squared theta will give me a plus 1, or just plus cotangent squared theta. And that's what I was trying to show. Trying to show that the left side does equal to cotangent to the fourth theta plus cotangent squared theta. And you can see how you can go back the other way. Cotangent to the fourth, again you can use this identity here along with cotangent squared. They're related to get the left side. So that's the solution for the first one. Now on the second identity, all we're going to do here is use the identity that the fact that sine of theta is equal to 1 over cosecant. In other words, sine and cosecant are reciprocals. If I solve this for cosecant, then I can write this as cosecant of theta is equal to 1 over sine theta. They're reciprocals. So I'm going to start with doesn't really matter, they're pretty much the same steps. Start with the left side, 1 plus sine theta over 1 minus sine theta. And I want to show that that is equal to what I have on the right side. So here what I do is I'm just going to multiply the numerator and the denominator by cosecant of theta. And that's legal as long as I multiply the denominator by the same thing, cosecant of theta. Because all I'm doing is multiplying the expression on the left side by 1. Cosecant over cosecant is 1. So it doesn't Doesn't change it. So let's just multiply through here. Cosecant of theta times 1 is cosecant of theta. Cosecant of theta times sine theta, that's 1. Because cosecant is 1 over sine, the reciprocals. On the denominator, cosecant of theta times 1 again. So cosecant again, theta times 1 is cosecant of theta minus, and then cosecant of theta times sine of theta, that's 1, again, the reciprocals. This is 1 over sine, that divides out, gives me 1. And there you have it. Now going back the other way, you can see how it works. If I multiply the numerator on the right side by sine, that gives me 1. Then sine theta times 1 is sine theta. On the denominator, sine theta times cosecant is 1. And then sine times minus 1 is minus sine theta. That's your solution. Thanks for watching. We'll see you next time.